Hey guys, welcome back to A-Level Physics. So in the previous video we went over all the topics that we will be covering throughout the series, such as mechanics and electricity and so forth. So in today's video we mentioned that we were going to start with mechanics, and specifically in today's video we're going to be going over statics. So statics covers several different areas, and one of those areas is forces and calculating them, resolving them, and finding out the resultant. So what is a force? Let's go over what a force is firstly. A force is a vector quantity. So a vector quantity is something that has magnitude and direction. So if we were to relate this to forces having magnitude means the size of the force. So I guess if we had a 3 Newton force and a 5 Newton force, the 5 Newton force would have a greater magnitude than the 3 Newton force. And the direction is pretty obvious, which is the direction in which the force is acting. And we'll represent this by angles. So for example, we've got a diagram at the bottom which shows us that a 5 Newton force is acting at 30 degrees to the horizontal. So in this case, the magnitude is 5 Newtons and the direction is 30 degrees to the horizontal. Now let's say we had 2 different forces, or more than 2, but in this case we'll take 2, that are acting in different directions. As you can see here, we've got one F1 force and we've got another one of F2, and they're acting in different directions. And to solve these, or to find a resultant, we can use the parallelogram rule. I mean, there are different rules, but this is one rule out of many. So to work this out, we kind of draw out the parallelogram using these 2 forces and then meet them up. And then since the force is acting from point O, so the resultant force would also be act from point O. So the beginning of resultant force would be from point O, and the end would be where I've circled it, where the 2 lines join up. So let's try and apply this to an exam style question. So let's say we've got a 5 Newton force acting 30 degrees to the horizontal, and we've got an 8 Newton force acting directly downwards. So if we were to draw this out in the parallelogram form, as you can see here, so since we've got the 5 Newton force here, so it would be like that. And then let's quickly use black because it would be a bit better. So 5 Newton force, and we've got the 8 Newton force down here. So now if we were to roughly draw out the parallelogram, it would be like this. Oops, I've extended a bit further than I need to. There we go. So now this is a rough parallelogram. Obviously I'm doing this freehand. In the exam you may get a diagram, but if you don't, you will have to use a ruler and use the information provided to draw out the diagram. So now we've got a rough diagram, we have to label the parts. So we've got 8 Newtons over here, and this will be 8 Newtons because parallelogram opposite sides are equal, so 8 Newtons here as well. This would be 5 here, so with this. And we also know that the angle is 30 degrees to the horizontal. As you can see, it's not exactly 30, it's a rough drawing, so obviously it won't be accurate. Now, since we know that's 30, we can use our intuition to work out that since these 2 are corresponding angles, we can work out that this is also 30 as well. So if this is 30, since this is a right angle, this angle here would be 60. So we've worked this out using basic intuition. So now all we have to do is use a cosine rule, and for those of you who don't know what the cosine rule is, I'll write it out for you. Cosine rule, wait 1 second, and this would be a squared equals b squared plus c squared minus 2bc cos a. So a in this case represents the resultant force, which I forgot to label here. Remember, make sure to label everything that's in the question. So this is the resultant force here. And in the question it also asks us to actually work out the direction in which r is acting, so we need to work out this angle theta here as well. So now we know those 2, we can work out r, so r squared equals 8 squared plus 5 squared, because those are the 2 other sides, so 8 squared plus 5 squared minus 2 times 8 times 5 cos 60, because that's the corresponding angle to the side r. So now if we were to put that into the calculator, we should get 7 for that. And now we have to work out what theta is, so that's a little bit more trickier. So now we have to use the sine rule, so let's go ahead and use the sine rule. So sine rule is pretty simple, which is the side corresponding to the angle, sine A over sine A, equals B over sine B. And let me just put this in capital to show that's an angle. So now A would represent R, which is 7 over sine 60, and B would represent any other angle side you want, but since we're working out theta, it will be suitable to use 5, so 5 over sine theta. Now if we were to rearrange this and make sure that it makes sense, sine theta equals 5 sine 60 over 7. And if we were to inverse sine and find out the answer, we would get a good round answer of 38.2. So this is the angle at which it's acting at from the downward direction, and 7 is the magnitude of the force. So now if we move on to a different type of question, instead this time it's not asking for the resultant force, it's actually only asking for the angle. So they actually provide the resultant force. So when they provide the resultant force, you know that there's something else that they want to find. So in this case they're asking for the angle, as I said. And now all we have to do is redraw that, redraw the actual parallelogram. So let's draw that out again. There we go. And this should roughly end about there. Since the resultant is literally straight, it would end about here. Obviously mine's a freehand, so it's going to be a bit rough. And if this is theta, this is the angle that we have to find. Since this is f, this would also be f. This is 10. This is also 10. So because even though this is rough, when you do it with roulette, it's obviously going to be neater. We can assume that this is 90 because it is a right angle triangle. Since the resultant force is acting straight, it's acting 90 degrees to the 10 Newton force. So we can just use Pythagoras Theorem here, which is a squared equals b squared plus c squared. So in this case, f squared would be equal to 10 squared plus 30 squared. And the answer for this would be, so it's a decimal number, but since we have to work out what theta is, let's leave it in third form, so 10 root 10. So it doesn't, so we don't get any rounding errors. And in order to work out what theta is now, we can just use the sine rule like we did before. Or we can also use the Parallelogram rule, whichever one's easier for you. So if you use the Parallelogram rule, it will be sine theta equals opposite, which is 10, over f. In this case, f is 10 root 10. And since these two cancel out, it will be 1 over root 10. So if you work this out, we get an answer of 18.43. But let's leave it to one decimal place, so 18.4 should be fine. So now if we move on to the last example, which is a little bit more difficult, since you don't get much in the question, and it looks a bit confusing as well. But don't be worried, don't be too distraught by the question. It's very easy to draw this parallelogram. If you go like that, and then you kind of form the parallelogram based off intuition, and as before, the resultant would be straight along here. So now we've worked out that we can add in all of the forces, I guess, and this would be F. So with this, and this would be F here as well. So since we know this is 120, and we've got all the other values, all you have to, and we can also label this as 30 because the question provides us with that. But I forgot to label it in the actual question, so sorry about that, guys. But yeah, so now all we need to do is use the cosine rule as we did before. So in this case, f squared equals 30 squared plus 60 squared minus 2 times 30 times 60 times cos 120 would be the result for f squared. So to work out f, just pop that into calculator. So now we get a value for f as 30 root 7. So in order to work out what theta is, I forgot to add that was actually in the question. But to work out what theta is, all we need to do is use the inverse of the cosine rule, which is essentially cos A equals, or you can just rearrange it from the cosine rule formula, but if you memorize the formula, it will be a little bit easy for you. B squared plus c squared minus a squared over 2bc. So a in this case would be theta, so cos theta, and the angles corresponding to a would be 60, so we have to use 30 squared plus 30 root 7 squared over, minus, in this case, 60 squared, and 2 times 30 root 7. So this comes out to be 40.8. So as you can see, there are several different methods to answer these sort of questions, and there's a lot of intuition needed. For example, the rules, the formulas. I don't think they're provided for the physics exam. They may be provided for the maths, but not for the physics one. So those are the formulas, and these need to be memorized so they can be applied for questions such as these. So if you'd like to have a go at a few more exam style questions, I've got 3 more below here. You guys can have a go. You can pause the video and have a go at them. But that has been it for today's video. I'll be moving on to resolving forces, using other methods to resolve forces, calculating forces, until we finish mechanics and we can move on to a brand new topic. But I hope you enjoyed today's video, and thank you for watching.